This marks the last chapter in our unit on antiretroviral therapy, and we have 3 more classes of drugs to cover: entry inhibitors, fusion inhibitors, and integrase inhibitors. So, as the battle unfolds, let's highlight these stages of the viral life cycle and illustrate how King Arthur and the rest of the antiretrovirals defend against HIV at every turn. First, the history of this conflict. HIV infects host immune cells such as macrophages, dendritic cells, and CD4 T cells. And so, our evil retroviral wizard has seized the neighboring castle. Let the Crusade cross theme represent the letter T as in T cell. Once incorporated into host DNA, it commandeers the host machinery to transcribe viral genes. The HIV structural genes GAG, POL, and ENV specifically code for polyprotein precursors which incorporate into a new virion. And so, after seizing the T castle, the HIV wizard commandeers the castle's workers to assemble an invading ship, much like the HIV virus assembles a virion to bud off and invade the next cell. As this brand new invading virion ship heads for Camelot, notice it has prisoners on board in the center of the ship, gagged. This is because the GAG structural gene has coded for virion core proteins, P7 and P24. And that's also why the gagged prisoners are tied around a sundial. Remember, 24 hours a day, 7 days a week for the core proteins, just like the guard here watching these prisoners 24/7. The ship has sent out a small landing party, their boat labeled Envoy. This is because the ENV structural gene codes for virion envelope proteins, such as GP41 and GP120. So while it might look like a harmless diplomatic envoy, these outer troops represent the viral envelope proteins crucial for infiltrating the membrane of the next host cell. Here's where 2 important antiviral drugs come into play: entry inhibitors and fusion inhibitors. The outer wall of Camelot will represent our defending host cell membrane. And let's first focus on the main gate and highlight the activity of entry inhibitors. For HIV to infect a cell, its surface glycoprotein GP120 must bind to the host cell's CD4 molecule and a chemokine receptor, CXCR4 or CCR5. This GP120 is like HIV's army battering ram. And notice that we've incorporated the number 120 into its design. Well, these invaders can only gain entry by making contact with CD4 and the chemokine receptor. At Sketchy, we depict a CD4 helper T cell as a little helper squire man with 4 feathers, usually going around and helping out other T cell knights. Remember that T-shaped Crusader cross as well. These are T cells we're talking about here. Besides making contact with CD4, the HIV virion's GP120 molecule also binds the CCR5 receptor on the host cell, which is depicted by the cool CCR banner he carries, as well as the banners at the entrance of the castle. However, before the 120 battering ram makes contact, in comes Mayor Avarok, the entry inhibitor, a brave knight rearing up on his mare. Mayor Avarok binds to the CCR5 receptor, so we've drawn him brandishing the CCR5 banner as well. Since Mayor Avarok binds exclusively to CCR5, not the CXCR4 receptor, the strain of HIV virus should be determined before starting therapy. If the virion had attached successfully, the next step would be membrane fusion. And this is where fusion inhibitors join the fray. While the GP120 battering ram was for HIV entry, the GP41 surface protein is for HIV fusion. So enemy troops are seen here at the castle wall trying to adhere with these GP41 hook shots. But before fusion can occur, in comes Infevertide. Remember that fusion sounds like Infevertide. And it works by binding these GP41 viral surface proteins, just like our cell membrane defender who is deflecting the invader's GP41 hook shots. I want to reiterate where these GP120 and GP41 surface proteins came from. The ENV gene coded for them, and that's why these viral attachment weapons are unloaded from the Envoy. Resistance to entry inhibitors and fusion inhibitors can result from mutations of the HIV ENV gene, which can make altered GP120 and GP41. Also, a test question may involve the initial processing of these viral surface proteins in the host cell's endoplasmic reticulum. So remember, the M gene encodes for these surface attachment proteins, which are first sent to the host cell ER for processing, because they have to be sent to the cell membrane, thus incorporating into surface of a budding virion. Notice the reef around the ENV boat kind of looks like the ER, the processing center for virus surface proteins. If HIV successfully enters a host cell, viral RNA is released from the nucleocapsid and transcribed into double-stranded DNA by reverse transcriptase. And so our evil retroviral wizard has penetrated the castle wall. He's using his reverso transcriptome spellbook, that's reverse transcriptase, to turn his single-file RNA army into a double-file DNA army. It's at this step that the NRTIs and NNRTIs make their move. So we've brought back King Arthur and Queen Elphavir from our NRTI and NNRTI sketches, respectively. They take action by inhibiting reverse transcriptase. Resistance to NRTIs and NNRTIs is due to mutations in the viral Pol gene. The Pol structural gene is responsible for making enzymes such as reverse transcriptase. If altered, it can produce enzymes resistant to binding. Enter Paul the Blacksmith, a blacksmith of enzymes. He's here representing the Pol gene coding for proteases, the blades, reverse transcriptases, the spellbooks, and integrases. Integrase will be represented by the keys he produces to unlock the nucleus of the host cell, so that the double-stranded DNA army can infiltrate the host DNA. The double helix staircase at the center of the castle represents the host DNA. Don't worry though, it's locked and guarded by the integrase inhibitors that work by binding viral integrase. Raltegravir is an integrase inhibitor that disrupts the ability of double-stranded HIV DNA to integrate into host chromosomes. An exam question may also word this as preventing the transcription of HIV mRNA, because if the viral DNA had integrated, it would then use host cell RNA polymerase to produce some viral mRNAs to code for protein production. Remember where all these enzymes came from, because it's key to understanding resistance. Paul the Blacksmith represents the Pol gene, which encoded for reverse transcriptases, proteases, and integrases. If the Pol gene is mutated, resistance develops to NRTIs, NNRTIs, protease inhibitors, and integrase inhibitors. Alas, the double-stranded army has unlocked another passage to the DNA staircase with a mutated key, and it looks like the integrase inhibitor at the door was slacking off a bit. Notice that he's not paying attention, instead shamelessly devouring a crispy chicken value meal, from the local butcher shop. A bite out of the chicken leg is our recurring symbol for rhabdomyolysis, a rare side effect caused by integrase inhibitors. Alright kids, we've finally reached the end of this Arthurian cycle. Let's sum up this timeless legend into a few important points. The gagged prisoners on the invading ship represent the GAG structural gene that codes for core proteins at the core of the ship. Think of P7 and P24 because those gagged prisoners are guarded 24 hours a day, 7 days a week. The ENV structural gene codes for virion envelope proteins such as GP41 and GP120. These will be unloaded by the ENV envoy, which releases the first wave of viral proteins, crucial for infiltrating the membrane of the host cell. Because they are envelope proteins, they're processed in the host cell ER before being sent to the surface of the budding virion. One of these viral envelope proteins is GP120, the battering ram. It must make contact with CD4, our helper T-cell Squire, and CCR5, the banner he carries. Enter Maraviroc, the entry inhibitor which binds CCR5 to prevent virus entry. The other envelope protein is GP41, the hook shot important for virus fusion. This is blocked by enfuvirtide, the fusion inhibitor. Once HIV enters the cell, viral RNA is turned into double-stranded DNA by reverse transcriptase, our evil retroviral wizard spellbook. Reverse transcriptase is inhibited by King Arthur and his NRTIs, as well as Queen Elphavir and her NNRTIs. Reverse transcriptase is encoded by the viral Pol gene. Paul the Blacksmith is also responsible for making proteases and integrases. Integrases are the keys that can unlock the nucleus of the host cell, so that HIV DNA can integrate with host DNA. Fear not, the DNA double helix staircase is guarded by the integrase inhibitors. Thus endeth this noble and joyous book entitled L'Amour d'HIV.